this video, I will talk about how we can solve quadratic equations by the graphical method. Take a look at this question. Suppose we want to solve the equation x squared plus 2x minus 2 equals 0. In this equation, the left-hand side x squared plus 2x minus 2 cannot be factorized, so the factor method that we learned cannot be used. However, there is another possible way to find the solutions of this equation. That is to consider the graph of y equals x squared plus 2x minus 2. And this is the graphical method that we're going to learn in this video. To obtain this graph, first of all, we need to plot some points on a coordinate plane. Let's consider the case when x is equal to minus 3. Then y should be equal to 1. And now we can plot the point minus 3, 1 on this coordinate plane. And then we need to consider more cases to plot more points. For example, when x is equal to minus 2.5, then we should know that y is equal to minus 0.75. Therefore, we can plot this point minus 2.5 minus 0.75 on this coordinate plane. We can repeat this process by considering different values of x, and then we can plot more points. Now we can see that these points somehow follow a trend, and these points can be joined by a smooth curve. In mathematics, this smooth curve obtained from a quadratic expression is called a parabola. Once we obtain this parabola of y equals x squared plus 2x minus 2, then the roots of the equation that we need, x squared plus 2x minus 2 equals 0, are just the x-intercepts of this graph. The x-intercepts of this graph refer to the x-coordinates of these 2 points. They are the intersections of this curve and the x-axis. From this intersection, we can see that the x-intercept is about minus 2.7. And from this intersection, we can see that the x-intercept is about 0.7. Therefore, we can conclude that the roots of this equation are minus 2.7 and 0.7. These two numbers are correct to one decimal place. By the graphical method, the results are always approximations. They can never be exact. Now let's take a look at another example. Suppose we want to use this graph to solve minus 4x squared plus 12x minus 9 equals 0. Same as before, we need to look for the x-intercepts, but in this case, there is only one x-intercept. The x-intercept in this case is about 1.5. Therefore, we can conclude that the root is 1.5, correct to one decimal place. Finally, let's take a look at this example. Suppose we want to use this graph to solve the equation 4x squared minus 7x plus 5 equals 0. Again, we need to look for the x-intercepts, but in this case, there is no x-intercepts. In other words, there is no intersection of this curve and the x-axis. Because there is no x-intercept, there is no root or no solution, so our conclusion is that there is no real roots. Here we say that there is no real roots. We have the word real here, because for quadratic equations we can have complex roots, and in this case we can only conclude that there is no real roots. To conclude, to solve a quadratic equation, we can make use of the graphical method, and in this method we just need to look for the x-intercepts of the graph.